All right, what's going on, guys? So this is S.22 point slope form, and we're going to graph an equation. All right, so point slope form is, well, we'll click my pen there, y minus y1 equals m times x minus x1. All right, so what we're going to do here is we're going to change this equation into slope-intercept form, which is y equals mx plus b. And then we're going to graph, because we have graphed from this. Okay, we've graphed from this before. We're good there. All right, so what we're going to do is we want to solve for y. So our equation is y plus 6 equals negative 1/5 times x minus 5. Okay, so we're going to solve, I'm a dot line here. We're going to solve for y because we wouldn't get y by itself. So the first thing we're going to do in this particular equation is we're going to do our distributive property. All right, so negative 1/5 times x is negative 1/5 x, and negative 1/5 times negative 5, a negative times a negative is a positive. And that's going to be 5 over 5, which is going to be 1. All right, and then we're going to bring down, let me get my color right here. We're going to bring down everything else that we haven't used yet, which is y plus 6 equals this now. So we want to get y by itself. All right, now to do that, I'm going to have to subtract 6 from both sides. And what we do to one side, we have to do to the other. All right, and now we're going to, all that's left, these will cancel. All that's left is y equals negative 1/5 x, and 1 minus 6 is going to give me negative 5. So now I have this in slope-intercept form. Okay, once I have it in slope-intercept form, now we can graph, because we know that our slope is negative 1 over 5, and my y-intercept is negative 5. So we go to our y-axis, we're going to go to negative 5, plot that point, and then use my slope. And remember, this is rise over run. So we're rising negative 1, which means we're going down 1, and we're running 5, which means we go right 5. 1, 2, 3, 4, 5, point there. Down 1, 1, 2, 3, 4, 5. And I can make as many points as I want on this graph. Remember, your slope, if you run out of room, your slope can change. It can be 1 over negative 5. These two fractions, their slopes are exactly the same, because a negative divided by a positive is a negative, and a positive divided by a negative is a negative. So if I go back to my y-intercept, I can also go up 1 and left 5. Up 1 and left 5. And that will put me on the same exact line here. Okay, so that right there is one way to do it. Now, another way to do this is, remember, this is point slope. Okay, so point slope form means we need two things. We need a point and a slope. So my coordinate point here, okay, my point would be, well, if I click this pen, all right, if I look up here, remember, in point slope form, your coordinate point is, there's your x1 and your y1. Okay, things to remember, this is y minus y1, which means if this is a plus 6, that's not a positive 6, it's actually a negative 6. Okay, if this is a minus 5, then that's actually a 5. So my point here would be 5, comma, negative 6. Okay, my slope is my number that's in front of the parentheses, which is here. So your slope is negative 1 over 5. All right, so if we were to graph this, and we didn't know how to do this, we know my point is 5, negative 6. So let's do this. We'll just do this in blue. So if I go over 5 and down 6, I click the pen first. Come on, read. There. And then I would go down 1 over 5. Notice now, this is on the same exact line. Everything is lining up. Okay. So you can either solve this point slope for y and get your slope-intercept form, or you can pull your point and your slope from the point slope form equation. But again, please, please, please remember that when you pull that point, the point is not negative 5, positive 6. Okay, it's y minus y1, which means your y1 is going to be the opposite of this, and your x is going to be the opposite of that. So instead of negative 5 is positive 5, so positive 6 is negative 6. That'll be your point. Okay, so two different ways to graph from point slope